start looking at questions 1 and 2, okay? So both of these have to do with supply and demand, okay? When companies want to sell a product, they must consider how much to charge for it, the price of the item. They want lots of customers to buy it, but they also want to make a profit in the cost of making the item to cover the costs, okay? So we're going to explore this dilemma as a system of equations, okay? So I want y'all to go ahead and work on 1AB and part question 2 as well. So I'm guessing our talking means we've answered our questions.
Yeah.
Maybe.
So for 1A, okay, so a company wants to sell I can't talk. So a company wants to sell a subscription for their magazine. They do some market research to predict how many people will buy the subscription. The demand for the subscription, good gravy, okay? So our demand for the subscription depends on the price and is given by the equation Q is equal to 126 minus 7P, where P is the price of the subscription and Q is the quantity of subscriptions. So that is our demand equation. Is the slope of that line positive or negative? Negative. Okay? Because remember, slope is what is in front of our variable, which in this case is negative 7P. So our slope is negative. What does that tell you? The line is going to go down. So
The higher the price, the lower amount of quantity.
the lower the demand, because that's what this one represents. So the higher the price, the lower the demand. Now we're going to look at B. So it says, if the subscriptions are sold for $5, how many subscriptions will be demanded? So what do I need to do to figure that out? Plug in 5 for P. So we're going to do Q is equal to 126 minus 7 times 5. What is that? It's not negative. What is it? It is 91. Just 7 times 5 is negative 35, but we had to do the whole thing. Okay, so negative, or not negative, 91 subscriptions are demanded. If they sell them for $5 a piece. Subscriptions. All right. Now, the quantity of subscriptions the company is willing to supply is given by a different equation. Okay? So the supply equation is given by the equation Q is equal to 3.5P minus 10.5, where P is the price the subscription is sold and Q is the quantity of supply. Okay, so if the subscriptions are sold for $5, how many subscriptions will the company supply? What do I need to do to figure that out? Plug it in. So we're going to plug in, we get Q equals 3.5 times 5 minus 10.5. What does that equal? So 7 subscriptions supplied. So if they charge $5 for the magazine, they are willing to supply 7, but 91 is demanded. Are they able to meet the demand for they charge $5? So should they charge $5 for their magazine? No, they should probably charge a little bit more than that. Okay. So I want us to go ahead and we're going to look at question 3. So question 3 asks us, at what price is the quantity demanded the exact same as the quantity supplied? So how would I figure out when demand is the same as supply? What would I need to do to figure that out?
Input the number into Q.
Not quite. We do need to do something with Q. What do both equations have in common? Well, even without the plugging in the 5, what do they both equal? Q. Yeah, the number of, they both equal the number of subscriptions, right? Q. Does Q equal Q? Yeah, it's the same, right? Q equals Q. So if I'm trying to find when they are the same, I'm also trying to find where they are equal. So I can take our supply equation. So we're going to take our demand, which is 126 minus 7P. And we're going to set that equal to our supply equation, which was 3.5P minus 10.5. So we're literally just figuring out where demand equals supply. That's all we're doing. Okay, so go ahead and solve this equation for me. All right, y'all should be working on your problems, not talking across the classroom. So we solved that for P. And what does P equal? 13. So that's telling us we should sell it for $13. And I also want us to figure out what that means for our supply and demand. Okay, so we're going to plug it into both equations. So we have our demand equation. We're going to do that first. So 126 minus 7 times 13. So somebody use a calculator and tell me what that is. Yes. What'd you get? 35. Okay, so that means the demand is 35. Now let's do the same thing, but with our supply. So we're going to do 3.5 times 13 minus 10.5. What does that give us? $35. So at $13, is supply and demand the same? Yeah. So that's what we're going to put here. So for 3, at a price of $13, $35 subscriptions are demanded. And 35 subscriptions are supplied. So what we just did was a real life application of systems of equation. Supply and demand is just a very easy example of that. So we're going to look at a graph of this same problem. So I want us to look at page 2, okay? And we're going to go ahead and we're going to talk about question 4. So question 4 tells us that both lines are graphed below. And it wants us to label the line that represents demand and the line that represents supply. So of the two equations, which one had a negative slope, supply or demand? Demand. So the line with a negative slope is demand. Which one has a negative slope, the solid one or the dashed one? So the dashed line represents our demand. Okay, and the solid line represents our supply. Because we knew the demand had a negative slope. And so that's how we made that decision. A lot of times graphs are labeled for us, but the easiest way to tell is slopes. Okay, so now it says, is charging $15 a good idea for the company? So if I go over here to where our price is 15 and I look at where that is on my demand and supply, is that a good idea for the company? Yes or no? Why not? Demand is lower than the supply, right? So they're going to have excess magazines. So that would not be good for business. Okay? How much should the company charge? What was that? 13. Okay. Why is 13 good? Yep, because that's where our supply and demand is the same. There's no excess. They're making enough money to cover it with their supply, and they're not having a bunch of extra left over because there's no demand. Okay? Just like how we had to set the graphs equal to or the equations equal to each other to solve it, we just look where the graphs are equal to each other, which is where they intersect. Okay, now, for number 7, it says, for what prices will there be a shortage of subscriptions? So where will the supply not meet the demand? What was that? Under 13. Or we could say at less than $13, there is a shortage. Or we could say there is less supply than demand. So we're going to kind of formalize that just a little bit. So a system of equations, okay, is where we have two or more equations with the same variables. Okay? So we're going to have two or more equations with the same variables. The solution. To find the solution graphically, you are looking for the point, or you're looking for the point where the two lines intersect. So graphically, where they intersect. So in this example here, we could see it at 13. Algebraically, it is the point that makes both equations equal, okay? Or we can say makes both equations true. Okay, so we're going to talk about the types of solutions we can have. So we can have one solution. We only get one solution when the lines intersect. So I want you to draw any two intersecting lines. It does not matter what they look like. Just make two straight lines that intersect. The point at which they intersect is your solution. And that occurs when you have different slopes. All right. We have no solutions when we have parallel lines. If I have two parallel lines, do those lines ever intersect? No. Okay, so that's what gives us no solution or the empty set. And when do we have parallel lines? The same slope. Okay, then the same line. So if I have one line, and then the other equation in the system is the exact same line, so we have to graph it on top of that. It is the exact same. How many times do those lines intersect? Infinitely, okay? You have infinitely many solutions. Or you can think of it as the solutions are all real numbers. Which to write all real numbers, we do an R with two lines at the back. Okay? It's a capital R where the back of the R has two lines. We talked about that way back in Unit 1. That was like day 1. Yeah, a minute ago. Okay. Whenever we have the same line, it will have the same slope and the same what? Same slope and the same y-intercept. Okay. So that is the things we're looking for when we're talking about solutions. Okay. So we have another word problem question we're going to look at on page 3. Look how cute Syl is. I guess I need to change my background now because that's got a ghosty on it. I don't know. We'll have to figure it out. I might can find a picture of her in front of the Christmas tree from last year. Every year after we put our Christmas tree up, we put her in her Christmas PJs and we do a photo shoot of her in front of the tree. It's very adorable. She gets very annoyed about halfway through when her face stops looking happy and starts looking like... But I'll show y'all a funny picture here in just a minute. All right, so Ms. Stetcher needs 50 pieces of candy to fill her candy jar. A fun-sized candy bar costs 32 cents, and a roll of Smarties costs 12 cents. She has $10 to spend. The graph shows a system of equations for this scenario where X is the number of fun-sized candy bars and Y is the number of Smarties. So let's first talk about what equation is what. So the dashed line is the equation 0.32x plus 0.112 or 0.12y equals 10. Does that represent the total number of candies or the cost of the candy? Cost. That is the cost of the candy, or the price of the candy. Okay. Then the solid line, it is represented by x plus y equals 50. So what does that represent? Yeah, the total number of candy. All right, so we're going to determine which points A, B, C, or D best match the description we were given. Okay, so a combination of Smarties and fun-sized candy bars that fills the jar and fits the budget. Would that be A, B, C, or D? C. We're looking where it is both. Okay, a combination of Smarties and fun-sized candy bars, that is not possible given the constraints. D. D is not on either line. It is not possible. Okay. Now we have a combination of Smarties and fun-sized candy bars that fits the budget but overfills the jar. Okay. Y'all were right on the first guess. What was y'all's first guess?
B.
B. Why is B right?
Because the cost is higher than the amount.
Yeah, the cost is on the line, so the cost is good. But it's more than the total number. Yeah. Because how many Smarties alone is in that? 60. That's a lot more than 50, right? Okay. Now, which one is a combination of Smarties and fun-sized candy bars that fills the jar, but it is not possible with the budget? A. Because A is more than the budget. All right. So now, how many fun-sized candy bars and Smarties should she buy? So how many fun-sized candy bars should she buy? 30 candy bars. Or not 30. What is that? 20 candy bars and how many Smarties? 30 Smarties. Because that is roughly where that point is at. 20, 30. All right. Now we are given a system and it asks if a point is a solution to the system. So if the point is a solution, it will make both equations true. So let's see if it does. So what do you think I need to do with the point to figure out if it's a solution? Plug it in. Okay, so we're going to start with our first equation. And we're going to plug it in. What do I need to plug in for y? So we get negative 4 equals 2/3 x. But what is x? Minus 8. Okay. So we get 4 equals, what is 2 times 6? What is 12 divided by 3? So we get 4 minus 8. What is 4 minus 8?
Oh, wait, negative.
Mm-hmm. Is that a true statement? Does negative 4 equal negative 4?
Yes.
Yeah. So is it a solution for that first equation? Yeah. So now, but to be a solution for the system, it has to be a solution to both. So we have to check the second equation. So for that second equation, What do I need to plug in for x? So we have 6 minus 2 times, what is our y? Equals 7. So we have 6. What is negative 2 times negative 4? Positive 8. What is 6 plus 8? Does 14 equal 7? So is it a solution for the second equation? So can it be a solution to the system? All right. So we're going to go ahead and look at how to, or we have a couple extra questions I forgot about. Never mind. 4. Okay. So 4 gives us the line Q is shown on the coordinate plane. That line that you are given is Q. It wants you to sketch a line M so that the solution to the system of lines M and Q is negative 2, 8. So sketch a line that intersects that point. It could look like whatever you choose, as long as it intersects that point. So that intersects that point. That could be our line M. You could also draw it to look like that, to look like this, to look like this, this. Basically any way that intersects that point. It could look like that. Ooh, maybe not like that. That's a bad line, but we're just gonna go with it. Okay, now, so all it has to do that is intersect at negative 2, 8. Okay, sketch a line Z so that the system of equations representing Q and Z has no solutions. What type of line would I need to draw to Q? A parallel line. I think the slope of that line is 3 over 4, so it's going to go down 1, 2, 3 over 1, 2, 3, 4. I think. Or is it down? That's not right. There is right.
Does it matter where I go?
It could be below it even further. It could be above it. As long as it is parallel, you are good. Okay, it has to be parallel. To Q. Okay, then for questions 5, we're going to determine how many solutions the system, or how many solutions the system has. Okay, so we're going to look at our slopes. Okay, so for A, what is our slope of y equals negative 4x plus 10? Negative 4 is the slope, right? What is the slope of y equals 8 minus 3/4 or 3/5 x? Negative 3/5. Are those slopes the same? No. So that means our lines will intersect how many times? So there is one solution. All right, for B, what is our slope for y equals negative 2x minus 9? Okay, what is our slope for y equals negative 2x plus 1? Negative 2. Are those slopes the same? Yeah. Is the y-intercepts the same? No. So that tells me that they are parallel. So that means how many solutions do they have? 0 solutions. So these lines intersect, which is why they have one solution. These lines are parallel, which is why they have no solutions. I'm going to do a third example for us. So C, if I have y is equal to 2/3 x plus 4. And the second equation is y is equal to 4/6 x plus 4. What is the slope of that first equation? 2/3. What is the slope of the second equation? What is 4 over 6 the same as? In both of these problems, our slope is 2/3. What is our y-intercept in both of those? 4. So if both our slope and our y-intercept are the same, that means they are the same line. Which means how many solutions? Infinitely many solutions. So just by looking at the slopes of lines, we can determine how many solutions we have. Okay, to determine the actual solutions, there are 3 different methods we're going to do. Okay, we're going to start the first method, the easiest method today. Okay, so we actually know how to do that. Okay, so I want us to go ahead and look at solving by graphing. So we're going to look at graphing 2 linear equations to find their point of intersection. And we are going to make sure we understand that the intersection represents the solution to the system. So first, we are going to rewrite the equations in slope-intercept form. What is slope-intercept form? Mx plus b. All right, so not all of our equations will need to be rewritten, just the ones not in slope-intercept form. Then we are going to graph the lines. Then we're going to identify the solution. We're going to do question 1 together. So for question 1, we're going to start with the first equation. So when I look at this first equation, y equals x minus 8. What is our slope? What is our y-intercept? -8. So I'm going to go to graph. I'm going to find my y-intercept. Then I'm going to use my slope and go up 1 over 1. How many points do I have to put to make a line? 2. Okay. The more points you put, the more accurate your line is. I tend to put a few more points on these solely because I've got to find the solution, so I want my line to be as accurate as possible. Okay, now for the second equation, okay, we have y equals -2x plus 1. What is our slope for that second equation? -2. What is our y-intercept for that one? What? 1. So to graph it, I'm going to go to where y equals 1. And then I'm going to use my slope of -2. How do I use a slope of -2? What do I need to do? Down 2, then which way?
Right.
Down 2, right 1. Down 2, right 1. And so where is our solution? -3, -5. So our solution is the point 3, -5. And then I want y'all to do the exact same thing for number 2.
Jasmine Warner to report to main office. Jasmine Warner to report to main office. Thank you.
Y'all go ahead and do number 2 for me. Yes. When Peyton gets back. Y'all should be graphing number 2. What did we get as our solution? Negative 2, 8. And our graph should look about like that, okay? Like I said, the way to make these the most accurate is to put more points on there. That's the best way to go about it. Whenever we start tomorrow, I want y'all all to grab a ruler. Today you're good because class is almost over, but we're going to make sure we grab rulers tomorrow. So we have about 10-ish minutes left, like 9 now. So we're going to go ahead and finish, or not finish, we're going to do question 3. So question 3. Is this first equation in slope-intercept form? No. So we have to first put it into slope-intercept form. So to put any equation into slope-intercept form, what do we need to solve for? We're going to solve for y, okay? Because we're trying to get it to the form y equals mx plus b. So y has to be by itself. So what do I need to do to get y by itself?
Add 3x.
Add 3x. That will be the quickest way to get y by itself because y also has to be positive and by itself. So we get y equals 3x plus 8. So to graph that, what is my y-intercept? What is my slope? 3 over 1. Can I fit a point going up 3 to the right, 1 on this graph? So I'm going to go down 1, 2, 3 to the left. So down 3 to the left, 1. Down 3 to the left, 1. All right, now we're going to look at the second equation. Okay, for our second equation, is it in slope-intercept form? No. So we have to put it in slope-intercept form too. We have negative x plus y equals negative 2. So how do I do that? Add x to both sides. So we get y equals x minus 2. What's our y-intercept there? And then what's the slope? Up 1 over 1. Okay, and I can also put points going the other way if I want to. So just by doing that, what is our solution? Negative 5, negative 7 is our solution. Okay, then the last thing we're going to do today is number 4. So I want us to go ahead and talk about number 4. And when you're going to do the part of the first question by ours together, and then I'm going to let you finish it. Okay, so for number 4, is that first equation in slope-intercept form? So we have to put it in slope-intercept form. What do I do to put x plus 2y equals 4 in slope-intercept form? Move the x. How do I move the x?
Wait, was the last one negative?
Yeah. What do I do to move the x? So I get 2y equals negative x plus 4. Now what do I do? By 2. So I'm going to divide everything by 2. And I get y equals negative 1/2 x plus 2. I can use that there is an understood 1 in front of that x to rewrite that as negative 1/2. What do you notice about these two equations? They're the exact same. That's the same line, right? How many solutions is that going to be? Infinitely many solutions. We still need to graph it though. So we're going to go to 2. Then we have down 1 to the right 2. And to show it, you can either highlight over the top of it, or you can just extend your line out to both ends. with like little dash arrows to show that it's the same line. All right, and that is where our lesson for today stops.